All right, continuing with our review of our chapters test. This is 6. This will be Form E. Again, the questions are the same, the answers are the same, but they have been scrambled on Test F. And hopefully this is the type of work you'll need to show. Now, all of the answers are listed here, and I do write the answers out on your paper as well. But the key to all this is to how do you do them and what work do you need to support them? And that's what I've done. So again, if we had more room, we could have put them there, but it doesn't work out that way. "30 questions, okay. Now again, this ties in directly with the numbers on Form E. And here all we're asked to do is to substitute what x is. We put an x there, add these two together, do the division, and we get this as our answer. And here again, we just had to substitute a 3 for the x, 3 for the x in function notation. This is 27 plus 6 is 33 over 3 times 7 is 9 times 3, I should say, 27, and it simplifies to this. Now here they're asking what is the domain of our x value. We equate the denominator to 0, solve it, x equals 9. So if x were a 9 here in the denominator, it would make that denominator a 0. So that would be undefined. So our domain then of x is that it comes from negative infinity up to just before 9, then in union just after 9 to positive infinity. So another way of looking at this would be all real numbers but x cannot be a 9. And then we got on to doing these, which are sort of a challenge, where we had to factor. So we look at our top. Is there a common factor? Yes, I could factor an 8 out of this, get that. An 8 out of there, get this. The 8's cancel out, and then this is my answer. For number 5, we factor that into its conjugates. We factor out the 4. Now, one of these cancels out, and we're left with r minus 3 over 4. Here we factor out the 4, factor out the 4. Again, the 4's will cancel out, and we get this. But they also wanted us to indicate what restrictions do we have in terms of x in our denominator. Well, we equate our denominator to 0, so x equals 8. So x could not be an 8. That would make it a 0 in the denominator. So therefore, there's our answer, and there's our restriction. Now, for number 7, here we have 3 fractions, and what we had to do to each of them is to factor them. And fortunately, they're not very difficult to factor. Now here, initially it was division, So I had to change it to multiplication, and to save a little room, I then flipped it. So this is the flipped one. That's how you do multiplication of fractions. Again, you start looking for common factors. Well, there's one. There's one over here. There's another one over here. And then we could factor an x with an x. So we're left with 6 over x plus 6. And again, this was originally set up as a division. I changed it to multiplication and flipped this. The only one that can be factored is this one. I factored it into its conjugates, canceled out these, and then I have this over z. And they do want you to leave it in factored form. Okay, now in this next one, this is straight multiplication. So I factor the top into its conjugates, factor the bottom, and then I can see what I can cancel out. Well, I can cancel out one of these and one of those, and I'm left with this. Okay, so I didn't give you the hardest ones to do. There are some that are a little more challenging than this, but wasn't too bad. All right, number 10. As we look at number 10, it's in function notation. They want us just to simplify. So I factored the 6 out of there, got this. Factored the 9 out of there, got this. Then I canceled out common factors. And then they also wanted to have what are the restrictions of P in the domain. Well, P could not equal 0, and then P could not equal a positive 1. So here, if P were 0, that would make that denominator a 0. And if P were 1, 1 minus 1 is 0, would have made this denominator a 0. So those are our restrictions, and there's our simplification. Number 11, we're now going into adding. We just want to note, are our denominators the same? Yes. So then we just add our numerators. X plus 2x is 3x. 4y minus 1y is 3y. Now here I could factor out a 3 from each of these terms, get this, and now I have a common factor. So these will cancel out, and there's my 3. For number 12, they wanted us to see what's our greatest common factor. Well, we factor this to this. We factor this to this. Now the rule for the greatest common factor is the greatest number of times a factor is used in any one factorization. So here we have an 8. It's only used once. Here we have an a plus 3. It's used once there and once there. The greatest number of times is once. So we need an 8 and an a plus 3. Then our other factor is a. What's the greatest number of times a is used? Once. So there is our answer. All right, at number 13, again, they want us to add these. But notice on this one, the signs are reversed. Here the 8y is a negative 8y. Here the negative 9x is a positive 9x. Now a technique we have is we can factor out a -1 from this, which is what I've done right here. Factor out a -1, reverse the signs, and I also reverse their order. So now that's my denominator. Now I can take this negative sign, which is in the denominator, and move it up to the numerator. That's what I've done, because there's only one negative sign somewhere. Here it is outside. I could put it by the bar, or I could put it by the y up in the numerator. That's what I chose to do. So now I have x minus y all over my common denominator. This one's sort of tricky and not too bad though. Okay, here's the typical rational expressions where the denominators are different. So first step, pick out the lowest common denominator, which is actually the combination of both of them. Then multiply each of these so they have this denominator down here. Well, this one is missing the y plus 4. This side is missing the y minus 3. So that's what I'm indicating I'm doing here. I'm going to FOIL. I get this. I FOIL. I get that. I combine like terms. Y squared plus y squared is 2y squared. A positive 6y and a negative 4y, a positive 2y. 8 plus 3, 11. And we leave our denominator in factored form. Again, it's sort of nice in the sense that this denominator and this denominator are the factors of this denominator. So there's my common denominator. I leave it in factored form. So this one is missing this. This one is missing this. Now, note that originally this was a minus something. Well, I made it plus, and I moved the negative sign up there. It's a little easier to work when you have it like so. So here we distribute, and I get this. Here we distribute, and I get this. This just stays the same. Now I have a negative x squared and a positive x squared. They cancel out. I have a negative 12 and a positive 12. They cancel out. So all I'm left with is 10x, 4x plus 6x, which gives me my 10x. Now, for some of you, you may have to pause the tape to see it in more detail. Write it down. This is what I expected the work to look like. Again, here the denominators are the same, so we just have to add our numerators. 4z plus 18z, 22z. A positive 2 minus 17 gives me a negative 15. And it's just over my common denominator. And they were asking, what is the qualification here? Again, if you solve the denominator for 0, or you find what would make it a 0, you get x equals negative 11. So in this, I meant to say z. Z cannot be a negative 11. That's the qualifier. Okay, finally we're getting to rational fractions now. What's our common denominator? Well, 2 times 5 times x. I multiply each term by that, because here I can cancel out my 5x's. Here I can cancel out my 2x. And here I cancel out my 10, which is 2 times 5. So I'm left with a negative x there, a positive 5, and 2 times 3 is 6. All my denominators are now 1s. So I've gotten rid of my fractions. So I add this up. This is 11. Negative x is that. I divide everything by a negative 1. And this becomes then a negative 11. This becomes a positive x, which is what I have here. I can write it here again, I guess. There you go. Here it becomes a positive. There's my negative. Or just change signs. That's the shortcut way. Okay, number 18. Now, as we look at number 18, we see we have 3 fractions. Common denominator are y plus 2, y minus 2. That is the conjugates of these. So I multiply every term by that. Here the x plus 2's cancel out, and I'm left with that. Y minus 2 cancels out, I'm left with this. Notice this was a negative sign. I put the negative up here, made this positive. It's easier to work. I multiplied through, combine like terms. Y is 9. Now these weren't too hard. Again, I didn't pick the hardest ones. Let's raise it up a little more. Number 19. Again, function notation, it says this is equal to that. So I just set it up this way, multiplied everything by x. Here the x's cancel out. Here I get 15x squared minus 2 minus x. I transpose that x to the other side here. I now have it in standard form. I factor it, equate each of my factors to 0. There are my answers. Here again, they're the conjugates of this. Multiply every term by this. Here these cancel out. I'm left with that. Here this one cancels out. I'm left with this. Here they both cancel out. I'm left with a 4. I distribute. I'm watching the signs. Group like terms. This is what I get for an answer. This one is very similar to this one up here. Got to multiply everything by n. Now when you do it, you get this, which is a perfect square trinomial that factors into its binomial squared. Equal this to 0. We get n equals a negative 5. Now it's negative 5 and negative 5. When you get the same answer, you only write it once. Okay. Here, someone can get a job done in 1/5 of an hour, 1/6 of an hour. How much time working together? This is right from our notes. So our common denominator is 5 times 6 times t. Here the 5's cancel out, we get 6t. 6 cancels out and we get 5t. Here the t cancels out, we get 30. Add our t's together, we get 11. Divide both sides by 11, we get 30t hours, which is just under 3 hours. If it were 3 hours, it would be 33 over 11. Here we have somebody going upstream or whatever. They're two different people, I guess different rates, and we're using the distance formula, but what they said was time was equal to each other. So this is time equals time. Now, when you have something set up like this, you can just cross multiply. So you get 196R, then R times this is that, this times that is that, and I see I had that, actually I copied that wrong. That's supposed to be 720 here. Apologize for that. When I hit the number, it hit the wrong button. Yes, but then I corrected it here, but I forgot to do it up there. Okay. I subtract this from both sides, I get that. Now I divide this by that, I get this. Now if you put that as your answer, that's wrong. That's one of the choices. But this is the slower person. They wanted the faster person. So be careful, what were they asking for? They were asking for the faster rate. How do you find that if you solve for the slower rate? Well, you just add 4 to it, because they're saying this person's rate is 4 more than the other. So 45 plus 4, 49. There you go. Okay, last page coming up here. Here they're asking us to solve for certain letters. Well, first thing, from a long time ago, get rid of the fractions. Multiply both sides by 2. Here the 2's cancel out. Then get rid of parentheses. And I get this. Then transpose this to the other side. When we do so, it changes its sign. And then we divide both sides by h. The h's cancel out. And then this is our answer right here. I could have written it again, but that's it right there. All right, now for these are all proportion problems, and direct and inverse. Again, we said whenever we have direct proportion, y equals kx. But there they're saying it relates to z, so we put the z there. And we just substitute. Then we want to solve for k. To find our constant of variation, k is 1/5. So there's our equation. In this one, it was inverse proportion, and we said always write y equals k over x, and they give us y as 28, x is 5. Multiply these two together, that's what's going to give you k. So you now have y equals 140 over x. That is the equation of inverse variation for those specific forms of data. And then here, this is distance equals some constant of variation times the weight. It's a direct variation. It stretches 19 centimeters. When you have 6 kilometers of weight, what's your constant of variation? Just divide both sides by 6, and you get 19/6 times k is that. You get your new distance now when you put a weight instead of 6, 19. 19 times 19 is a big number. Divided by 6, and you get this. And they tell you to round off to 2 decimal places. Okay, these last three are pretty straightforward. Again, this is pressure to weight or something. Let's see here. It's inverse relationship. I don't remember the details now. And they originally gave you what P was. They gave you what W was. You had to find what K is. Just multiply these two together. You get this. This is your equation of inverse variation. And they're giving you this new value for weight. Divide that into that, and you get 28 point, I think is 79 or something. You round it to 8. This one is direct variation, but here x is squared. They give you y, they give you x, and we have to square our x, which gives us 16. We now divide both sides by 16. That gives us what k is. And then there's our equation. Now for the last one, again, it was volume, directly related to temperature, inversely proportional to pressure. This is Hooke's law or someone. And they gave us all these values. We had to find what k was. K is 12. And then to get our answer, there we go. So we put 12 where k is. They're giving us a new temperature and a new pressure. And there is our volume. Pretty cool. Okay, again, we're keeping these around 30 minutes, which is good. This one's just 27.